Here's a second application from the book Stewart, Redlin and Watson. And here we have an airplane which is flying at a speed of 350 miles per hour at an altitude of 1 mile. So the altitude remains at 1 mile and it travels 350 miles per hour. And the plane passes directly above the radar station at the time we start counting, so t is 0 when the plane is directly above the radar station. S is the distance from the airplane to the radar station, and d is the horizontal distance from the radar station to the plane. And part A says, express the distance s in miles between the plane and the radar station as a function of the horizontal distance d, which is measured in miles, that the plane has flown. So A says, express s as a function of d. Well, we know s and d are related. They're sides of a right-angled triangle. So we have an expression, thanks to Pythagoras, that s squared is the sum of the squares of the other two sides, so it's d squared plus 1. And now s is positive because it's a distance, so s is the positive square root of d squared plus 1. So this gives me an expression for s in terms of d, where we see s is a function of d, and the formula is given by the square root of d squared plus 1. Now B says, express d as a function of time. And we see that d does indeed vary as time varies, as time progresses, d gets larger. And so d is a function of time t. The question is, can we write down a formula for that? Well, we have this airplane is traveling at a constant speed of 350 miles per hour. So after t hours, it's going to have covered a distance of 350 times t. So this is 350 times the number of hours which have passed. Here t is measured in hours, and of course d is measured in miles. Now part C says use composition to express s as a function of t, of time. We see s is a function of d and d is a function of t, so we can use composition of functions to get an expression for s in terms of t. So what is s as a function of t? Well, s is s of d, and so s as a function of t is equal to s composed with d of t. In other words, we're just going to substitute the formula for d in terms of time for d in the formula for s. And that's exactly how composition of functions work. And so this is equal to s. Our expression for d of t is 350t. This is d. And this is equal to the square root of d squared, so it's that, plus 1. And now we can tell how s is changing as time changes.